So next is exercise 2.2. Find the zeros of the following polynomials and verify the relation between the zeros and the coefficients. So this question has two parts. First, we have to find the zeros of the polynomial. Then we have to verify the relation between zeros and the coefficient. Now, take the first question, that is x square minus 2x minus 8. First, we have to find the zeros of the polynomial. So, we have to first write or split the middle term, that is minus 2x, in terms of two numbers whose sum will be minus 2x and product will be 8x square. So, we can write it like this, that is x square minus 2x minus 8 will be equal to x square minus 4x plus 2x minus 8. See here, minus 4x plus 2x you will get minus 2x, and minus 4x plus 2x will give you minus 8x square. So that's correct. So that will be equal to, taking the common factor out of this, we get x minus 4, and taking 2 out of this, we get 2 into x minus 4, and on taking again the common factor, x minus 4 into x plus 2. And to find the 0, we have to equate this term to 0, that is x minus 4 into x plus 2 equal to 0, which implies that x equal to 4 and x equal to minus 2 are the zeros of the polynomial, that's a given polynomial. Then next we have to find the relation between zeros and coefficient. What is the relation? That is sum of zeros equal to minus of coefficient of x divided by coefficient of x square. So sum of zeros, what are the zeros? 4 and minus 2. So you will get 4 plus minus 2, that will be equal to 2. And on the right hand side, minus coefficient of x. What is the coefficient of x here? Minus 2. Minus of minus 2 divided by, what is the coefficient of x square? 1. So you will get it to be also equal to 2. So 2 equal to 2. So the first relation is proved. Second is product of zeros. What is the product of zeros equal to? Constant term divided by coefficient of x square. What is the product of the zeros? What are the zeros? 4 into minus 2. That will give you equal to minus 8. What is the constant term here? Minus 8. What is the coefficient of x square? 1. So that will also give you minus 8. So you have proved that product of zeros is equal to constant term by coefficient of x square. Thus, the relationship between zeros and coefficient are proved or verified in the first question. Now, moving on to second question. Next question is 4s square minus 4s plus 1. So this is a polynomial, quadratic polynomial in the variable s. So first we have to find the zeros. How to find the zeros? The same method, we have to first factorize that. So how to factorize? On splitting the middle term, we get minus 2s plus 1. And on taking the common factor, we have, this 2s into 2s minus 1 and minus 1 into 2s minus 1. And again, on taking the common factor, we have 2s minus 1. We will take 2s minus from both sides into 2s minus 1. So, to get the 0, we have to equate this equal to 0. Equate this equal to 0. So, we have 2s minus 1 equal to 0 implies that s equal to 1 by 2. So, same for both the case, s will be equal to 1 by 2. So, that means the value of zeros are 1 by 2 and 1 by 2. So, now the first condition to prove is sum of zeros is equal to minus of coefficient of x divided by coefficient of x square. So that means sum of zeros. What are the zeros? 1 by 2. Next one is again 1 by 2. And what is the coefficient of x here? Minus 4. Minus 4. What is the coefficient of x square? 4. So this will give you 1. And 1 by 2 plus 1 by 2, 1. So the first relationship is verified. The first one is verified. Next one. Next, what is the next one? Product of zeros is equal to constant term divided by coefficient of x square. What is the constant term here? Look at the question. Constant term is 1. What is the coefficient of x square? 4. Next, product of zeros, that is 1 by 2 into 1 by 2. That will again give you 1 by 4. So 1 by 4 equal to 1 by 4. That means the second condition is also, the second relation is also verified here. Now moving on to the third question. So now consider the third question, that is 6x square minus 3 minus 7x. So this is of the form ax square, the constant term, that is c minus bx. So rearrange to make it more convenient. That is ax square minus bx minus c. So that will be equal to 6x square minus 7x minus 3. The same, these are the very same. Then now factorize this polynomial. That will be 6x square. So minus 7x. We have to write that as a sum of 2. So that its sum will give you minus 7x and product will give you 3 into 6x square, that is 18x square. So what will be that? That will be minus 9x plus 2x minus 3. So this is the number, minus 9x and plus 2x. So taking the common factor from this, we will have 3x as a common. So the remaining will be 2x and here we will have minus 3. From 2x and minus 3 there is nothing common, only 1. So plus 1 into 2x minus 3. And again on taking the common factor we have 2x minus 3. So remaining will be 3x plus 1. So to find the zeros, equate this to 0. Equating this to zeros, we will get 2x minus 3 equal to 0, which implies x equal to 3 by 2. Then 3x plus 1 equal to 0. This implies x equal to minus 1 by 3. So we have got two zeros here. What are the two zeros? So we can write the zeros to be 3 by 2 and minus 1 by 3. So the first is sum of zeros equal to minus coefficient of x divided by coefficient of x square. What is the coefficient of x here? Coefficient of x is minus 7. And what is the coefficient of x square here? It is 6. So that is a right hand side. What is the sum of the zeros? 3 by 2 plus minus 1 by 3. So find the sum of these numbers. That will be 6 will come at the denominator, into 3, 9, into minus 2. That will give you 7 by 6. That's the LHS by, I'm sorry here, there is one mistake here. So here we are writing it to be, there is minus 7. Here we have one more minus, sorry. So it will be again minus 7 by 6. So LHS is equal to RHS. So the first relationship is proved. Second is product of zeros. Product of zeros is equal to the constant term divided by the coefficient of x square. What is the constant term here? That is minus 3. Constant term is minus 3. Coefficient of x square is again 6. Then product of the zeros. What are the zeros here? 3 by 2 into minus 1 by 3. On cancelling common factor we get minus 1 by 2. Here minus 3 by 6, that is equal to minus 1 by 2. So LHS equal to RHS. So we have proved or we have verified both the conditions. So that comes the end of the third problem. Now moving on to the fourth problem. What is the fourth problem here? 4u square plus 8u. Fourth problem is 4u square plus 8u. See here we do not have any constant term. Constant term in this equation is 0. So now when you get a question like this, we need not have to factorize this x coefficient term. So we can directly take the common factor from this. What is the common factor? 4u. 4u equal to u plus 2. So we have factorized this, that is 4u into u plus 2. Remember, there is no constant term here. The constant term in this question is 0. Remember, the constant term in this question is 0. So what we have done is we have taken the common factor outside. So this is the factorized form. To find zeros, equate this to 0. That is 4u equal to 0, which implies u equal to 0. U plus 2 equal to 0, which implies u equal to minus 2. So these are the two zeros. What are the zeros here? Zeros are 0 and minus 2. Then first, to verify the relation, find the sum. Sum will be equal to 0 plus minus 2 will give you minus 2. This should be equal to the minus of coefficient of u. U is a variable here. So minus of coefficient of u. What is the minus coefficient of u? 8. And what is the coefficient of u square? It is 4. Minus 8 by 4 will give you minus 2. So the first relation is verified. Next is product of zeros. Product of 0 is equal to constant term divided by coefficient of x square. What is the constant term here? There is any coefficient? There is any constant? No, it is 0. Coefficient of x square, that is 4. Product of zeros. What is the zeros here? 0 and minus 2. 0 into minus 2 will give you 0. 0 by 4 will also give you 0. So thus the product of 0 equal to constant term by coefficient of x square is also verified here. Now moving on to the fifth question. Now we are going to do the fifth question, that is t square minus 15. So this can be done in two ways. For example, that is our first method, that is directly equating it to 0. Okay, we want to find the value of t. So t square is equal to 15. That is t is equal to plus or minus root 15. So we get two zeros. So what are the zeros here? Plus root 15 and minus root 15. Second method or secondly we can find like this t square minus 15 is of the form a square minus b square. A square minus b square is a plus b into a minus b. So what is a here? T. And what is b here? Root 15. So we have t plus root 15 and t minus root 15. So on equating this to 0, the same we get t is equal to root 15 and minus root 15. So we got the two zeros, plus root 15 and minus root 15. Now we have to verify the relation. What is the relation? First is sum of zeros. Sum of zeros equal to minus of coefficient of x. Here it is not x, I'm sorry, it's t divided by, here the variable is t, divided by the coefficient of t square. Okay, what is the coefficient of t? Is there any coefficient for t? No, there is no coefficient for t. So that's 0 by t square, it is 1. And sum of zeros, that is root 15 plus minus root 15, again we get 0. LHS equal to RHS. So this relation is verified. So the second relation is product of zeros. product of zeros is equal to the constant term divided by the coefficient of x square. What is the product of zeros? Root 15 into minus root 15. And here what is the constant term here? We have constant term to be equal to minus 15. And the coefficient of x square is 1. So RHS is equal to minus 15. LHS is also equal to minus 15. LHS equal to RHS. So this relation is also verified. So that comes end of fifth question. Now moving on to the sixth question. What is the sixth question here? 3x square minus x minus 4. So the same way as we have done earlier, we have to split the middle term. Okay. So what will come as the middle term? Middle term will be equal to minus 4x plus 3x minus 4. So here what we can do is that, can we take anything common from here? So equating this equal to 0 to find the zeros. So taking the common factor as x, we have 3x minus 4. Nothing to take common factor from this. Take 1 outside. 3x minus 4 equal to 0. On taking common factor and rearranging, we get 3x minus 4 into x plus 1 equal to 0, which implies a value of x to be equal to 4 by 3 and minus 1. So these are the zeros, 4 by 3 and minus 1. So the first relation is sum of zeros, that is equal to 4 by 3 plus minus 1 equal to, we have 4 minus of 3, that will give you 1 by 3. That is equal to, we have to prove that whether it is equal to the coefficient of x minus coefficient of x by coefficient of x squared. What is minus coefficient of x? It is minus 1. What is the coefficient of x square? It is 3. So we got it to be as 1 by 3. Here also 1 by 3, here also 1 by 3. So the first relation is proved. Next we have to find the product of zeros. What is the product of zeros? 4 by 3 into minus 1 will give you minus 4 by 3. And what is the relation? This should be equal to the constant term divided by coefficient of x square. What is the constant term here? It is minus 4. What is the coefficient of x square? It is 3. See, these are proved. So the second relation is also verified. So that comes the end of exercise 2.2, first part. The first questions, 6 parts. So the second question will be discussed in the next video. Thank you.